which you've actually kind of already done. We just have to do a little bit extra today. I do want to give a shout out to my latest YouTube subscriber. I want you to see my password here. That's right. I am up to, look at this, people. Look at this. 1,200 views, 29 subscribers, 29, double digits. I mean, I am a YouTube sensation. But anyway, shout out to our latest YouTube subscriber of the day, Mr. Brandon Summy. We are so grateful. Thank you. Always hit like and subscribe. Like and subscribe. JK. All right, now for the new information. I knew you needed that for today. The fundamental theorem of calculus, which we have talked about before. You have seen this lovely symbols. This is the integral from a to b of f of x dx. Okay, what is that? Well, the fundamental theorem of calculus says, well, that would be your f of b minus your f of a, where f is non-negative and continuous on the closed interval a, b. So here's really what I want you to understand, okay? When you see this, you need to be thinking of some curve, some function under that curve, where a is your lower limit and b is your upper limit. And then you've got the x-axis, and you are trying to find the area in between, okay? And that's what we did all of the first part of this chapter. We did Riemann sums, and we were noticing. But the fundamental theorem of calculus actually allows us to take then the integral and substitute b and substitute a in and subtract. And we can actually find that area. So pre-written these examples, I've already actually graphed them. You can obviously graph them on your calculator, but I am going to go through these, what do we have, six or so examples. All right, so here's what I want to see you do tonight. Find the area of the region bounded by the x-axis and the function x squared minus 1, where x is bounded between 1 and 2, okay? So what that means is if I were going to write this as an integral to find the area, I'm going to find the area from my lower bound 1 to my upper bound 2 of my function f of x, which is x squared minus 1 dx, okay? If you remember from the first part way long time ago, we had to graph these, and then we would draw our little region here. We are actually only concerning ourselves between 1 and 2, so it looks like a triangle, and we would kind of talk about that area if it was a triangle, but we put rectangles inside of it. We'd approximate it with limits. We're not going to do that anymore, okay? Yay, I know you're excited about it. We're going to do what we just been learning, okay? We're actually going to integrate this right now, okay? Because you know how to do the general power rule and the U substitution rule. So let's integrate this. What would be the integral of x squared? Yeah, it would be x, you add 1 and divide. So x cubed divided by 3. And what's the integral of 1? Yeah, so minus x, 1x. Now, you are going to integrate this from 1 to 2, which the fundamental theorem says, okay, let me go back right here, that you can then, once you've integrated it, you can now plug in b and then plug in a and subtract. Okay? So that would be 2 to the third over 3 minus 2. That would be plugging in the b. And you're going to subtract, now you plug in the a, which is 1 to the third over 3 minus 1. Okay? So this is f of b. This is f of a. And so what do we get here? Well, this is 8/3 minus 2. 8/3 minus 2 is 2/3, I believe. 1/3 minus 1 is negative 2/3. And then you subtract them, which really means you add them. So this is 4/3. 4/3. That area right there is 4/3. Now, if you remember on your calculator, just to show you, there's a wonderful little button called Math Num, and then go down to where it says F. I just passed it. Oops. It's not Math Num. Sorry, it's just Math. FNInt, number 9. And then this lovely thing will pop up, and then you can type in 1, 2, put in your function, which was x squared minus 1, and then put dx. And look at that, 1.33, which as a fraction is 4/3. Okay, so let's move on to our next one. Graph and find the integral from 0 to 1 of 4x plus 1 squared dx. 4x plus 1 squared dx. So this is a very tight parabola, and you're only going from 0 to 1. And you can draw these, but this is all the way at, if you put a 1 in here, this is all the way at a 25. So let's take the integral of this one. I wouldn't do the u on this one. I mean, you can do u if you want to, but because if you square something, I could just FOIL it out just as quickly. So this would be 16x squared, 8x plus 1, and we're going to integrate this. So I'm just going to integrate each one separately. And I think that's always easier. If I have to do a u, I'll do a u, but this is just much easier to do. So let's see. Add 1 would be 3 and divide. So 16x to the 3 divided by 3. Add 1 would be squared. So it'd be divided by 2 would be 4x squared. And then add 1, it would be 1x. And now you're going to plug in 1, the upper limit. So that would be 16/3 plus 4 plus 1. That's plugging in 1 everywhere I see an x. Get me that number. Then you're going to subtract, plugging in a 0 everywhere you see an x. Well, that's actually really easy. This would make this 0, 0, 0, so you're going to subtract 0. So all you have to do is 16/3 plus 4 plus 1, which is about 31/3, which is about 10.3. And again, you can check that on your calculator. Okay, moving on. All right, so this one I had to put a little sticky note over because it had so much mess underneath. We're going to integrate from 0 to 3 e to the 2x dx. Okay, so e to the 6, if you plug a 3 in, is a lot. It's like 400 and something. So that's why I had trouble graphing it. I was like, oh, whoa, this is really huge. Here's your e to the 2x function. You're going to integrate from 0, which is always at 1, all the way up to 3. So we're going to find this area right here. And again, the fundamental theorem of calculus says just take the antiderivative of it. So we need to do this as a u because this is an e problem. So this needs to be our u. So we have to do the whole u du thing. So this is u, which is 2x. Your du would be 2 dx. I don't have a 2 dx, so I got to divide out the 2. So a half du equals dx. So this right here is a half du. I'm going to now rewrite this. If I rewrite this, this would be the integral from 0 to 3 of e to the u du. And then that 1/2 you can actually just pull out. Sometimes I just left it right there, but it doesn't matter. And now what is the formula to integrate an e to the u? That's just e to the u plus c, but we don't need to write the plus c. If there's a 1/2 in front, we just attach that 1/2. So this would just be 1/2 e to the 2x. And now I'm going to integrate that from 0 to 3, meaning I'm going to plug in my upper bound 3. So 1/2 e to the 6 minus, now I'm going to plug in my lower bound, 1/2 e to the 0. And remember, that's not going to become 0. E to the 0 is 1. So this would be 1/2 e to the 6th minus 1/2. And you can approximate that if you would like to, but I'll give it to you. It's 201.2. So that area right under there is 201.2, which kind of makes sense. I mean, look, we were going all the way up to 400. So let's do another one here. This is now we're going to integrate -3 times the square root of x from 1 to 4. This does go to 0, 0, by the way, but we're only integrating from here to here. So I would actually rewrite this as the integral from 1 to 4 of -3x to the 1/2. And add 1 and divide. So what do we get? Add 1 would be 3/2, divide by 3/2. 3's are going to cancel, so I end up with -2x to the 3/2 from 1 to 4. Okay, so now plug your 4 in. That would be, so it's going to have to do it 4 to the 3/2. So -2 times 4 to the 3/2. -16. Okay, minus, plug in 1, would just be -2. So you plug in your upper, plug in your lower. Upper, lower, upper, minus lower. And -16 minus -2 is -14. Now question, why is this one negative? I thought we're talking about area here. Is area negative? Well, where are you located right now? That whole thing is under the x-axis. So your area is negative for this one. All right, almost done. Hopefully this is making sense. It's all coming together now. So you didn't have to do rectangles anymore. You just have to do your integrals and then plug it in. All right, so if you're given an absolute value, which you will on tonight's homework, and I mean, obviously I know you have a calculator, but they will ask you to graph it. Just a quick trick, if you want to find your vertex, you can set your what's in between the absolute values equal to 0 to find that vertex. So 2x minus 1 equals 0. X would be 1/2. That would be the vertex right there at 1/2. And you're going from 0 to 2, so you're actually finding this little triangle all the way to here. Okay? So another thing is when you're dealing with absolute values, the definition of an absolute value is you have a negative direction slope, that if this was negative, you could still take the absolute value and get out an answer. Or if it's positive, it's still the same thing. What that means is then you actually need to write this as two integrals. This one area and then this area. So watch what I'm doing here. I'm going to integrate from 0 to 1/2, low to high, lower to the first dot, of this is a negative slope of this function. So I want the negative of that one. So I want the negative 2x minus 1, which would actually be negative 2x plus 1 dx. So I'm going to integrate that. That would be this area right here. Then I'm going to add that to this second area. Now I know you're probably thinking, why is it add? I thought it was subtract. No, we haven't done the actual integral yet. We're just taking two areas together. This area goes from 1/2 to 2. So 1/2 to 2. And this area is the positive of what's in the absolute value. So 2x minus 1 dx. Okay, so we now have two integrals to worry about. So now let's apply the fundamental theorem to each one separately. So I got to take the integral of negative 2x, add 1, divide by that exponent would be negative x squared. 1 would be x. And you're going to integrate that from 0 to 1/2. Then you're going to do this one. Add 1, which would be 2, divided by 2 would be just x squared minus x. And you're going to integrate this from 1/2 to 2. So you're doing two at the same time because you have two areas. This is very important for what we're doing tomorrow. So let's plug my 1/2 in. 1/2 squared is 1/4, but it's a negative on the outside, so negative 1/4 minus, plug in your lower bound, which is 0. So that's just 1/4. This one, plug in 2, so that would be 2 squared is 4 minus 2 would be 2. Minus, plug in 1/2 now. 1/2 squared is 1/4. 1/4 minus 1/2. 1/4 minus 1/2. Did I do that right? Oh. 2 squared is 4 minus 2, yeah. 1/2. Sorry. 1/2 squared is 1/4 minus 0.5 is, oh, it's a negative. My bad. Negative 1/4. So that minus the negative, see, look at what happens here. Becomes positive, so that's 2 1/4. And now you add these two areas because they were two separate ones. So you would have 2 1/2 units squared. So this is 2 1/2 units squared. All right, weird, but it'll actually help you with what we're doing tomorrow. All right, last two things, which you probably might remember from when we did the properties of integrals. If you got x squared dx, remember it's a parabola, and you're going from a negative 2 to a 2. Anybody remember or want to remember what's going to happen there? Yeah, this area, isn't that going to be the same as this area? Okay, you could actually write this into two separate integrals, but it's just unnecessary. But watch what'll happen. You'll have, let's integrate this, x to the third over 3. I'm going to plug in your upper bound, which would be 8/3, minus, you're going to plug in your lower bound, negative 2 cubed is negative 8/3. See, they're the same, but when you subtract, they actually become positive 16/3. These areas are the same. Okay. If you have x cubed, remember it looks like this, and you're going to go from negative 2 to 2. Remember doing this? Remember this was a negative area. This was a positive area. What do you think is going to happen here? Well, let's see. This would be x to the 4th divided by 4. And we're going to plug in our upper one. 2 to the 4th divided by 4 is 4, minus negative 2 to the 4th is positive, divided by 4 is also 4. Aha. This would be, remember this was a negative area, this was positive, it made 0. And that has to deal with even and odd functions. Remember this was an even function. These two areas are mirrored. If this is an odd function, then they cancel each other out. All right. And again, you can check all this on your calculator, go into math, and then number 9, which is FNint. If you have those old school calculators, it won't give you the, fill in the integral blanks. You could still use it. You would type the function. So like for this last problem here, this x cubed, you would put x cubed here. Then you write comma x, always comma x, because you're giving it its definition. The lower bound, which would be -2, and the upper bound, which would be 2. And if you plug that in, you would get 0. All right. Try your homework. Make sure you show this work, by the way. I know you can do it all on the calculator. Bye.